Assalamu alaikum. There are several methods to analyze any sort of electric circuit. Here in this video tutorial, we will do nodal analysis with voltage sources. The main purpose to analyze any sort of circuit is we will have to find the voltage across non-reference nodes. Now in this circuit, there are two cases in which a voltage source is connected in circuit and we have to do it with nodal analysis. The case one is when a voltage source is connected between a reference node and a non-reference node. Like here in this circuit, we can examine that the voltage source of 10 volt is connected between this reference node and this non-reference node. So in this case, we will consider the voltage across this node V1 as 10 voltage. It's a universal rule. And the second case here is when a voltage source is connected between two non-reference nodes. Like in this circuit, the 5 volt voltage source is connected between non-reference node V2 and V3. For example, we have this circuit in which there are two current sources, 2 ampere and 7 ampere, and one voltage source, dependent voltage source. It's an independent source of 2 volt. Now we have to apply both the cases, case 1 and case 2 on it. First we will have to look at the voltage source. If there is any voltage source connected between reference node, that is ground, and non-reference node V1 and V2. So we have no voltage source connected across reference node and non-reference node. The second case, that is look at or find out the voltage source, if there is any, connected between two non-reference nodes. So here we have one voltage source of 2 volt connected between two non-reference nodes V1 and V2. So in this circuit, there are in this process or procedure, there are 4 to 5 steps you have to follow to analyze correctly any sort of circuit. So here the first step is select reference and non-reference nodes and assign voltages to all non-reference nodes. Ground, as you all know, that ground is always known as reference node, and the other nodes V1 and V2 are known as non-reference nodes. Now we have assigned voltage V1 and V2 to these non-reference nodes. And the second step is look at dependent and independent voltage sources according to case 1 and case 2. As we have done before that, if there is any voltage source between reference and non-reference node, no, there is not. So case 1 is not applied on this. And there is case 2 is look at if there is any independent source or dependent source connected between two non-reference nodes. So here it is. And the third step is identify supernode in this circuit. According to case 2, when a voltage source is connected between two non-reference nodes, like here it is 2 volt, and an element or branch of that circuit connected parallel to that voltage source, we will consider both of these as supernode. Now here is supernode of this circuit, and the third step also says that apply KCL on it. The third step is we will identify the supernode and then we will apply KCL on this supernode. And the fourth step is apply KVL and extract equation of that. Now the fourth step, you can see further in this video that we will apply KVL on this circuit. And the first step is after getting those two equations, we will solve those two equations by 3 methods. There are 3 methods to solve any sort of circuit or to solve 2 equations. One is Cramer's rule, second is by substitution method, and the third is by elimination method. 3. So according to third step, here it is supernode. We will consider it the circuit like this. We will extract this whole as a supernode. So here we will apply KCL on supernode. That is, according to KCL, the current entering the node is equal to current leaving the node. Here in this circuit, 2 ampere is entering the node. This whole is a supernode. We will consider this whole as a supernode V1 and V2. 2 ampere is entering the node, I1, I2 and 7 ampere are leaving the node. So according to KCL, we have this equation that 2 ampere is equal to I1 plus I2 plus 7 ampere. So according to Ohm's law, we will represent all those currents in terms of voltages across those elements or branches. Here is I1 is equal to V1 minus 0 divided by 2, and I2 is equal to V2 minus 0 divided by 4. So by putting the values of I1 and I2 in this equation, we got 2 is equal to V1 over 2 plus V2 over 4 plus 7. And by taking LCM and solving it little bit, we have this equation 8 is equal to 2V1 plus V2 is equal plus 28. And by rearranging and solving, we got the equation, first equation as 2V1 plus V2 is equal to minus 20. Here I have the same circuit. Now we will apply the fourth step, that says that apply KVL on the supernode or on that circuit. So we will neglect all those other elements as we have done in step 3. Now here we will simply suppose that voltage source of 2 volt connected between two non-reference nodes, and those voltage sources of or those voltage of non-reference nodes. Here we will apply KVL. So we have the equation that minus V1 minus 2 volt plus V2 is equal to 0. As you all know that KVL says that the sum of all the voltages in a closed loop is 0. So here by arranging this, we have minus V1 plus V2 is equal to 2. Now we will solve those two equations simultaneously, or by substitution method we can extract the value of V2 from this equation, that V2 is equal to 2 plus V1, and we have equation 1 as we done in step 3, that 2V1 plus V2 is equal to minus 20. We will put the value of V2 here in this equation. So we have V1 plus 2 is equal to minus 20 minus 2V1. By solving and arranging this, we got the value of V1 is equal to minus 7.33 volt. By putting this value of V1 in this equation, we have V2 is equal to minus 5.33 voltages. So here we have the voltage of those two non-reference nodes. By following these steps, you can simplify or solve any sort of circuit. Thanks for watching our video.